Okay, number 6. Nope, not red. Relative extrema. So looking at this diagram, I see 0, 0 is the local min. That's it, that's all. What is 7? Probably concavity diagram. So f double prime of t is 1 minus 3t squared times 2 all over this guy cubed. If you set that equal to 0, you get 1 is equal to 3t squared. It's the only possibility. So t is equal to plus or minus root of a third. That's when my second derivative is 0. Put that on a number line. Test points. So plugging in, say, 0 in here gives me positive on top. The bottom is always positive. So, and then I'm going to guess these are both minuses. And if you pick a large enough number, you'll see that the numerator becomes negative. If you pick like negative 1,000,000, also get a negative on top. So we have this concave up here, concave down, concave down. So this is an IP, this is an IP. That's what we'll talk about in 8. The IPs are so to find these y values, I would take, say, negative of root a third, plug it back into my original function f, calculate and get a quarter in both cases. Okay, now we're ready to sketch. So what I would do is I would put my inflection points, plot those. 0, 0 is a min. I think that's all I got, right? Let's start there. See how I didn't leave much space down here? Well, because the function is t squared over 1 plus t squared, right? That's positive number divided by positive number. It's always positive, so there's no action down here. No action. So don't leave any space down there. Don't waste any space. Okay, so I got a min at the origin, 0, 0. Then I got this root a third and got these ugly numbers here. What is root of a third? Who cares? What's more important is the horizontal asymptote. So it's over here, and it's also over here. Erase you. Okay, I wouldn't draw it in the middle. It's misleading. Okay, when x goes to infinity, or t goes to infinity, I'm either having this or this, right? Well, which one is it? Well, if it has to come back to this origin, right? So if it were the one on top, then it would have to do something like that. That would imply a maximum, but I never found a maximum, right? So Not going to be that one. It's going to be this one here. So similarly, it's going to be on the left like that. Now, a quarter. Where is a quarter? So if this is 1 here, then that's a half. That's a quarter. Root of third, who cares? We'll just say it's just say it's like here. And then it's got its mirror image over here. So these are my 2 inflection points. And what's happening? So if I look at my diagram here, it's going to be concave up in the middle. So I'm going to go through my min. Okay, up, concave, up. Go through my min, up, concave, up. And then it's going to switch to concave down at that inflection point. So, see that? Yeah, that's pretty good, Jordan. Not too shabby. Mirror image. Oh, that's not a nice. Try again. Something like, oh, that's even. Oh, whatever. Just there we go. Good enough. So it's concave down forever on the right. It's also concave down forever on the left. It's not going to work. So just, no, this isn't going to work either. Just who cares? Just concave down, respecting the asymptote. And there we have it. Label these IP. Should label my x-axis. Didn't really spend much time thinking about that. This is a plus a third. And this is minus a third.